We have been talking a lot about the impact of air pollution on human health. It's taken millions of lives, human life. And in Southeast Asia and Western Pacific region, according to current available data, more than 4 million people are dying. I would say that it's underestimate of current burden. This is PM2.0 related death based on available data, but we don't know a lot. Not all countries or areas or cities are reporting data on air quality. So the magnitude of the problem is huge. And in the Southeast Asia and Western Pacific region, just if you take the example of PM2.5, the standards are not met from 1 to 8 times. Previous speakers mentioned that over 60% of countries have standard, but in reality, enforcement is lacking. Good note that to see the overall progress in using clean foods for cooking in the households, but ambitions to achieve SDG targets is far from reality. I would like to draw your attention from the Lancet report on health and climate. This graph shows the contribution of different sectors to the mortality of population in the region. As we can see here, primarily more than 90% of people living in low human development in these countries are primarily relying on biomass. Then this figure is about 7% in high human development in these countries. And we talk a lot about the transition from fossil fuel to clean energy. And the previous speaker mentioned why we are lacking, why the progress is not made. What are the barriers? We can see one example here, for example. Only 2 to 3% of energy supply in high human development index countries are coming from renewable energy, and 11% in high human development index countries. And also we see major gap in investment to renewable energy. Investment to renewable source of energy increased by 4% compared to 10% to fossil fuels. This last year, Lancet Countdown highlighted that the world is going to the wrong opposite direction. We are transitioning from fossil fuel to clean fuel, but we really need to look at these numbers and discuss jointly how the change can be made in a progressive way. Here we see the overall annual mean concentration of PM2.0 in concentration in urban areas based on WHO data. Overall trend is decreasing, but very slow decrease. If compared to WHO air quality guideline level, for example, annual level is 5 microgram per cubic meter. Then both urban cities in Southeast Asia and Western Pacific region have to reach the WHO limit value from 7 to 9-fold. It's maybe easy to say that progress is not adequate, but really if you think about the healthy future population, we really need to accelerate the action and to achieve the recommended safer levels of set by WHO air quality guidelines. On this slide, I would like to draw your attention only on the important aspect that air pollution is the second leading cause of deaths from NCDs after tobacco smoking, preceding the diet, physical inactivity, and alcohol use. It's really the big public health crisis. In the Southeast Asia, in Western Pacific region, for example, over 100 people are dying per 1,100 population due to poor air quality. This is the trend for non-communicable diseases by main causes. Overall trend is decreasing, which is good news. But to achieve the SDG target related to reduce mortality and morbidity due to ambient and indoor air pollution, the reality is also far from to reach our ambitious goals. And in this, the last figure shows the structure of the non-communicable disease mortality. Predominantly ischemic heart disease, stroke, and chronic obstructive pulmonary disease are the main causes of mortality from non-communicable diseases in both regions. It was highlighted many times that air pollution, its negative impacts hit very hard vulnerable people, elderly people, and also demographic change, the ongoing demographic change in both regions, Western Pacific and Southeast Asia, puts a lot of needs to address this issue and work specific, come up with specific strategies and actions targeted to vulnerable groups. Elderly people have a lot of existing morbidities and health issues, in addition to non-communicable diseases, respiratory diseases, cardiovascular diseases. Emerging evidence indicate that air pollution causes type 2 diabetes and also cause neurodevelopmental issues, progressive dementia in older elderly people and adults, and also it affects our future generation, putting risk of children and starting from prenatal exposure to air pollution, also affecting their health in the future, later stage of their life. So I before mentioned that there is interlinkage between climate change and air pollution. I would like here to highlight that air pollution worsens the heat climate change, and it, especially exposure to particulate matter, increases the impact of heat mortality. I will not go through the impacts of heat on different parts because the previous speaker very elaboratively explained that about the different effect of climate change in all the sectors. I would like just to mention that last year, according to Lancet Countdown, it was the world hit the highest record over the 100 years, which shows that if the globe, the countries will not limit the increase of medium temperature to 1.2. If with current progress in mid-century, the heat-related mortality will be increased more than about 4 times. And dengue potential of transmission will be increased by over 20%, 40%. And also in Asia, coastal airlines will be suitable environment for transmission of catastrophic infectious pathogens. So it shows that all interrelated challenge of climate change and air pollution can aggravate negative impacts from both sides. So it's very important to I would like to highlight here the quote, the word from Lancet report, each moment of delay worsens the risk of people's health and survival. So we really know, anticipating these risks, today's meeting and will provide a lot of opportunity how to tackle the emerging challenges in adequate way. So I would like to now, maybe I have 2 minutes. Previous speakers mentioned that it's very important to implement WHO air quality guidelines. And I would like to ask, why do we countries, areas need to implement WHO air quality guidelines? Because implementing WHO air quality guidelines will save lives, improve the development, well-being. According to estimate, if WHO set a limit value for PM2.5, for example, implemented in this region, about more than 70% of lives will be saved. So this is enormous public health benefit of implementing WHO guidelines. What WHO guidelines do offer? It not only offers limit values, but it offers opportunities to provide. It provides evidence-informed knowledge on health impacts of air pollution based on latest scientific evidence. It also reference point for setting national standards, and also it provides flexible approach to set step-by targets to reduce air quality. It triggers action, discussion, science to policy to action discussion among different stakeholders to trigger sector-specific emission reduction measures. And also it provides very powerful tool to mitigate climate change. So very briefly about the what are the requirements look like in the national standards. About 2/3 of the countries set standards. But when we see the requirements set in the standards, we also need to work with the countries. not all the countries set standards for classic air pollutants for short or long-term exposure. And none of the countries at the moment set standards in line with the civil limit. We understand that reaching standard is a difficult, complex process, but we really need, countries need to make efforts to align these science-based recommendations of WHO. If we see the second graph here, compliance with existing standards, with the standards in Southeast Asian countries, Southeast Asia region and Western Pacific region is very low. Southeast Asia region, for example, none of the countries complying with the WHO air quality guidelines safer values. Overall implementation is in the range of interim target 1 or 2, which really requires, we need action to strengthen the standards and also to strengthen the enforcement. So I'm coming here to the end of my presentation. It's very important to address the sources of air pollution and in solutions to work all the sectors together. For example, in transport sector, energy sector, agriculture sector, cities. And so there are solutions, but the important thing is really solutions should be prioritized with the health co-benefits. And I'm very hopeful that this discussion will help, this meeting will help to unlock the challenges and effectively discuss what will be the priority interventions and how this can be scaled up across the countries. Thank you very much for your attention.
Thank you very much, Ms. Shinee. We will get back to you at the end of the session if there are any questions from the floor or online. It is now my pleasure to invite Ms. Leilani Dulguerov, who is an Associate Scientific Officer at the World Meteorological Organization, to share her presentation on the impact of extreme weather and changing climates on air quality. Ms. Dulguerov, the floor is yours. Kindly note we have allocated 12 minutes for your presentation.
Okay. Yes. Hello, my name is Leilani, and thank you for having me today. So as we know, climate change is characterized by increases in temperature, changes in precipitation patterns, and projected increases in extreme weather and environmental events. The anthropogenic activities that are driving climate change alter the composition of the atmosphere, both by increasing greenhouse gas concentrations and by emitting short-lived air pollutants. These changes in composition in turn affect radiative forcing, creating more feedback from climate change, as well as on natural emission sources and air quality. But there are uncertainties related to future changes in human emissions, model responses to climate change or emissions changes, and the natural variability of the climate system. These many complex interactions make future air quality projections difficult. Next slide, please. I want to look at some of these interactions. So climate change and wildfires. Well, heat waves, which will increase in frequency under climate change, create conditions of extreme temperatures and prolonged drought, which favor wildfire propagation. Wildfires emit large quantities of particulate matter and other air pollutants, leading to poor air quality conditions, as you can see from this example from the Canadian wildfires of last year. Next slide, please. Climate and land use changes also drive desertification, increasing the likelihood of sun and dust storms. Sun and dust storms can alter radiative forcing and cloud formation, which influence climate change in turn. Sun and dust storms also generate large quantities of particulate matter, which impact agriculture and human and ecosystem health. The large uncertainties in future projections, considering the interactions between sun and dust storms and climate change, exist because research and observations of the phenomenon are still sparse. Next slide, please. Urban areas are particularly sensitive to climate change impacts due to the density of human activities and heat trapping structures. They can be up to 5 to 10 degrees warmer than surrounding rural or semi-urban areas. This infographic, which is soon to be published, summarizes the WMO guidance report on the canopy layer urban heat island, which details the complexity of measuring, modeling, and monitoring urban scale environments. Next slide, please. So monitoring and forecasting atmospheric composition is complex, but essential in gaining a better understanding of future climate and air quality conditions. So I'm speaking to you today on behalf of the World Meteorological Organization, which is the UN specialized agency on weather, climate, and water. We're based in Geneva, Switzerland, and are supported by 193 members. The WMO coordinates the work of over 300,000 national experts from meteorological and hydrological services, academia, and the private sector. Next slide, please. And within WMO, the Global Atmosphere Watch Program, which is one of 3 research programs, focuses on applied research that enables atmospheric composition services which support policy. By providing high-quality observations, we seek to better understand the roles and impacts of aerosols, reactive gases, stratospheric ozone, and greenhouse gases. This research is driven largely by global societal needs. Next slide, please. We are structured around partnerships and research contributors from 100 countries, thanks to whom we support several international conventions, as well as the SDGs, and work with to deliver integrated products and services of relevance to society. The Global Atmosphere Watch, or GAW, strongly emphasizes quality assurance and quality control. And for this, long-term systematic observations are essential. Next slide, please. So how does GAW support these services and information related to air quality? GAW supports trend analysis and climate impact assessments by maintaining these high-quality long-term data sets. However, considerable challenges remain in our ability to provide atmospheric composition information from many parts of the world. As you can see from this map, there are gaps, and in places where these data cannot be obtained, the gaps are filled with low-cost sensors, satellites, or national air quality networks when possible. Next slide, please. Just to illustrate an example of how GAW contributes to strengthen data infrastructure, we provide guidance on low-cost sensor use. Low-cost sensor networks should be considered to support long-term measurement networks, but their limits should be recognized. They operate on a limited lifetime and cannot be calibrated to the same standards as national air quality networks or observational research networks like GAW, who have the capabilities to also conduct comparisons and analyze trends. Next slide, please. This is just an example of one of such trend analyses, in this case for atmospheric CO2 concentrations from the observation station in Idania, which is only possible thanks to the long-term nature of this data set. Next slide, please. GAW facilitates the translation from science to services through several initiatives. There are the Science for Climate Service initiatives, like the Measurement Model Fusion for Global Total Atmospheric Deposition, which combines measurements and model approaches to improve our understanding of total atmospheric deposition and create maps of use for policy and decision making. There's also the Integrated Global Greenhouse Gas Information System, which is a common framework for the provision of systematic services to user community to intend to reduce their greenhouse gas emissions. More on the mitigation side. Next slide, please. GAW also supports science for air quality and health services by coordinating global networks to establish warning advisory and assessment systems and facilitate model intercomparisons and benchmarking exercises. Next slide, please. Next slide, please, actually. Yeah. So GAL therefore coordinates atmospheric composition monitoring, data processing, and forecasting globally through all of these infrastructures. I'd like to highlight that there is a strong representation of GAL expert networks in Asia. Model intercomparisons and the development of early warning systems in the region are strengthened by the regional centers, which support sun and dust, wildfire, and air quality forecasting. There's also currently a pilot study for climate mitigation under the Greenhouse Gas Information System being conducted in China to measure the carbon sequestration capabilities of bamboo forests. Next slide, please. Besides the bamboo pilot project, GAL is also involved in other research projects at different scales. The FOCI project aims to improve uncertainties in climate models related to non-CO2 forces. I've added this figure depicting the framework for integrated services just to illustrate where this project is acting. So here on improving the modeling and prediction part. We're also conducting a study in Thailand, which you may hear about later, funded by the German Development Corporation and in partnership with the Thai Meteorology Department to enhance climate resilience in selected Thai cities by developing a similar integrated framework, but at the urban scale. Next slide, please. I'd lastly just like to mention that GAL publishes bulletins on all of our core topics, including those which I discussed today. This figure by chemistry analysis is taken from our latest air quality and climate bulletin and represents the differences in fine particulate matter for 2022 with respect to the climatology. We can see strong decreases over Eastern Asia, thanks to intense mitigation efforts that took place in the region. We also note observed increases in anthropogenic and desert dust emissions in parts of Africa, Central Asia, and the Middle East. Next slide, please. This is also a figure from the latest air quality and climate bulletin depicting the effect of heat waves on ozone, particularly in urban environments where the density of anthropogenic emissions and the intensification of temperatures enhance this process. And this just highlights the need for integrating urban services and to better understand the links between climate change and air quality. And then the next slide is the last. Yeah, we publish many bulletins and reports annually, and you can find more information on our studies linking climate change and air quality, among other topics, on our website. Thank you very much. And I think there's maybe one last slide.
Thank you very much, Ms. Dulguerov, for joining us so early in Geneva.
In
We
case
will
I
get
said
back to you.
anything wrong, we can attribute it to that.
Thank you very much. It is now my pleasure to invite Khun Pakorn Petchprayoon, who is the Director of the Office of GeoInformatics Product Innovation at the GeoInformatics and Space Technology Development Agency, to share his presentation on harnessing digital technologies for air quality management. Khun Pakorn, the floor is yours. Kindly note we have allocated 12 minutes for your presentation.
Thank you very much.
Thank you.
Good morning, ladies and gentlemen, and members of state and distinguished guests. So it is my privilege to appear before you today to share some of our work, knowledge, and experience in using of the technology, digital technology for air quality management. So we mostly suffer with PM 2.5 and other air quality problem in Thailand, particularly in the PM 2.5 for the PM 2.5. During the dry season, starting from January to February, in this area that we gather here in Bangkok, we suffer with a PM 2.5, and 2 months later, it's moved to the northern part of Thailand and affect to the most northern Thailand and our neighboring country. And here is also, we have this experience. We have the experience from this air pollution long time ago. Since we can observe it, digital technology or remote sensing satellite observe around the Earth, and also this record the data since 2002. And then here is some example that we see the thing that we cannot see before. So PM 2.5, air pollution, and everything is allowed us. We try to use the digital technology. Digital technology means the electronic tool, the device, system, resource, or the process that generate the data, analyze the data, store the data, and use all of this information to figure out the problem of the air pollution and manage it. So for the digital technology, we can monitor it by using the device from the satellite above the atmosphere. So like 800 kilometers above the surface, or 36,000 above the Earth's surface, or we can use ground station or the airborne. And also we do the Internet of Things to link all the data together and then use all of this data for analyze, and then we can predict it by using the model. And then the most important thing is we have to communicate to the people. We have to communicate to all the level of the people, both from the policy maker and the local people, and also try to track the emission source and identify it. So here is an example of the digital technology, all of the device that we try to understand. We try to see the behavior of the air pollution. If we understand it, if we see it, and we know their behavior, we know the source of this air pollution, we can tackle with it. We can figure out it, and then we can make it actionable policy for figure out the air pollution problem. So here, on behalf of GISTDA, there is the Thailand Space Agency. We use multilateral satellite data to monitor the air pollution. We use both near polar orbit and satellite remote sensing for the geostationary. So we get the data every hour and also every 15 minutes for the geostationary satellite. And also we monitor the other parameters that relate to air pollution, including land use, land cover, hotspot, and also other sort of the air pollution by using the multiple sensor of the satellite, both active and passive satellite. All of the data merge together, integrate together in order to see and map it. So with this information, we can map, identify which the area that have the very severe. We can monitor it to see how change of this situation, and also use the model to monitor it and forecast the situation in the future or in the decade. And also we measure it, quantify it, and compare it for the situation because air pollution is the problem of the area and time. Both temporal and spatial situation need to be updated. And then when measure it, I have talked about 4M, mapping, monitoring, modeling, and measuring. All of these 4M will useless if we cannot manage it. Now we come to talking about how to manage it and how to cope with the air pollution. So that means all the related parameters that affect to the air pollution, we need to observe it. So from the atmosphere, from the lithosphere, from the biosphere, also hydrosphere, we already have observed it. And we have to understand the interconnection or interlink between each parameter in order to understand the air pollution problem. And also, I come back to this slide again, because we analyze the data, we understand the data, but if we not use the data or we not share the data is useless. The more data that we use, the more data that we share, the more benefit we'll get to the people, will get to the society. So for the air pollution, for the scientific process, scientific academic process or study, we get the result, we provide the result, we provide the solution. But the main important thing is the public sector with the social sector, that people is the main thing that can drive and figure out and overcome the problem of the air pollution. And one of the things that we can do is try to convey this information to the people while using the mobile application. This is every people can get the data everywhere and every time. And also, we want to know more behavior. Since we study from the satellite and connect it to the ground station, so we want to know the behavior between the ground station and the satellite. So we cooperate with Korea, with NASA, and with the other country to monitor the behavior of the air pollution between the ground and above to like a 600 meter to see the 3 dimension of the air pollution, because air pollution can moving like a X, Y, and Z in 3 dimension, and also move to the 4 dimension with the temporal resolution. And also, we got this information for the preliminary data. So now we have the atmospheric profile, and then this is for just beginning. Now we get all the data. But the problem is, the most important thing is how we analyze and we understand all of these data and convey to the policymaker and convey to the local people. All of them have to see the same picture. When people see the community see the same picture, they will understand and then they will cooperate to solve the problem. And also, we need to know the behavior of the PM 2.5 and also other atmospheric air pollution by using the air-based change management. So every area, every time, they have the different phenomena. That means air change-based management is the most important one. And also for the digital era, digital twin is the most important one. We try to replicate the Earth phenomena by using satellite, observe the real thing and also the dynamic thing, the up-to-date thing from the satellite data with the multi-sensor, and also to get the data to analyze and make the phenomena in the digital world. And then the result or the phenomena from the digital world will go back to the real world in order to propose the strategy or the scenario or to the policy maker. And then they will see the problem or they will see the thing that we never seen it before in order to finish and try to stop the problem of the air pollution. So here is my conclusion. The digital technology are the transforming for the air quality management. So by providing the important data, so enable our people to better decision and making, and also empower all stakeholders to work for the clear air. So we hope that in the near future, we will see the clear blue sky in our region. Thank you very much.
Thank you very much, Kun Pakorn. We will get back to you at the end if we have any questions. It is now my pleasure to invite Ms. Diane Archer, who is a Senior Research Fellow with the Stockholm Environment Institute, to share her presentation on applying human rights-based approach for air quality management. Ms. Archer, the floor is yours. We have allocated 12 minutes for your presentation. Thank you.
Thanks very much. Let me just share my screen. Thank you very much, and thanks to EANET and UNEP and ESCAP for inviting me today to speak in this event. And I will be speaking about a human rights-based approach to air quality. Just by way of brief introduction, I am a researcher at the Stockholm Environment Institute Asia office, which is based here in Bangkok, where we have been doing research on the exposure and vulnerability of particular population groups to air pollution. So just to start off, I'm sure many of you are aware that in 2022, there was a UN resolution to declare rights to a healthy environment, which includes clean air. This isn't legally binding, but I think it sets a trend in the right direction to encourage different actors to really push towards achieving clean air in their country. In the region, we do know that the Philippines recognizes the right to clean air in legislation, and more countries are also pushing to have clean air bills, including in Thailand, where there are at least 5 Clean Air Acts currently being discussed by a parliamentary committee with the hopes of approving one into law at some point, hopefully this year. And recognizing clean air as a human right is really important for focusing attention and action, and that includes from the private sector as well. So there's a hope that by having this UN resolution, the impacts can trickle down into actual action on the ground to push for change. We also can use this resolution as a basis for legal cases by citizens. Quite interestingly, there have been a couple of cases in the region. So, for example, in Jakarta, a group of citizens sued the president, the Ministry of Home Affairs, the Ministry of Health, and the Ministry of Environment for failing to control air quality. The courts ruled in their favor. The president then filed an appeal, and it went all the way up to the Supreme Court, which ruled that the president had acted unlawfully and urged the president to carry out the actions ordered in the initial court ruling, including establishing ambient air quality standards. And then in Thailand, last year, Chiang Mai citizens filed a class action lawsuit against the Prime Minister and the National Environment Board for failing to act on PM 2.5. And again, the court ruled in favor of the citizens that the Prime Minister's office would have to issue an action plan within 90 days. So I think having or recognizing clean air as a human right can really be a basis for more action on tackling air pollution at its source. Unfortunately, we don't experience equal rights. We don't all experience equal rights. And there is inequality in society, and the same comes to air pollution. So not everyone is exposed to the same amount of air pollution, and not everyone is affected in the same way. And as Dr. Pakorn mentioned, we really need more and more data to really highlight the areas that are affected by the air pollution, but also at a very local scale, we need to understand which particular population groups are affected and how. And for example, things like your life stage, your personal health will affect how susceptible you are to air pollution. Socioeconomic factors like your education level, your migrant status, your ability to access healthcare, what kind of housing you live in will all affect your exposure and your susceptibility as well. And then exposure is also determined by the type of job you're doing or where you live, whether you're near to roads or factories where there are high levels of air pollution. And unfortunately, people who are at the sort of crossing or the intersection of all 3 factors will be the ones most at risk. But there's still a lot of work to be done to try and understand who these people are and how we can help to reduce their exposure. And a lot of this boils down to both structural and structural drivers of exposure to air pollution, and also underlying structural inequalities in the makeup of society. So, for example, in terms of structural drivers, the fact that there might not be any air pollution regulations, or they're not comprehensive enough, or they're not enforced fully, will be a factor driving heightened exposure. It might also be economic policies that favor the expansion of certain industries or sectors because they're putting economic growth ahead of health, for example, even if the health costs might be very high. So, for example, policies that promote the expansion of the industrial sector, or that promote certain types of crops, which we know are often a source of agricultural burning, such as maize, or expansion in the transport sector, for example, building more roads rather than investing in train or alternative public transport. Similarly, if there's a limit to public transport in the city, or it doesn't reach all parts of the city sufficiently, then this will encourage private car use and more pollution. Yes, as I mentioned, economic policies that favor the expansion of polluting industries rather than trying to highlight greener industries and jobs. And then in terms of the underlying structural drivers, these are issues like inadequate housing or segregation of neighborhoods. That means that poorer people often live in the most polluted areas, and their housing conditions might be such that they can't, for example, use air purifiers. Not only are they expensive, but they might not even have glass windows that they can shut to block out the air pollution. For those who are working in the informal sector, they might have limited access to healthcare and to social security. If they don't have access to paid time off when they're sick, then that increases their burden of exposure to air pollution as well, as they have to continue working. And then we find that often those who work in really high exposure occupations like mining or in industrial areas are often those who are migrant workers or who are from poorer backgrounds or less educated backgrounds as well. So there's a need to address other underlying basic human rights, like the right to education, in order to address the problem of air pollution from different angles. We still have many gaps in understanding the differentiated exposure and vulnerability because there are still gaps in data. Many countries have very poor coverage of air pollution quality monitoring. And this is where low-cost sensors can come in and play a role to help fill in the gaps as well. And then we find that in a review of existing research on air pollution exposure, health, and work, that the sectors most considered are usually formal jobs. So, for example, people who work as public transport drivers, as traffic policemen, or as office workers. But we found very little research looking at informal workers and their exposure to air pollution. The research is also quite biased towards cardiovascular disease risk, but not other diseases associated with air pollution, like stroke and diabetes. And so we still have gaps in terms of understanding the real impact of air pollution on people's health. And as part of this study, which I mentioned earlier, we also carried out a review of occupational health and safety policies across Asian countries. And in most cases, we found that air pollution is regarded as a work hazard, but not all kinds of air pollution are equally regarded as occupational health risks. So, for example, in the chart at the bottom, not all countries considered the vapors from chemical substances as a form of air pollution at work, for example. Not all countries as well will provide compensation for occupational disease caused by air pollution. So there are still inequalities in terms of the kind of workplace safety that people can expect in terms of limiting their exposure to air pollution. And this should also be targeted as part of regarding clean air as a human right at work, as well as in terms of general ambient air quality as well. And again, as per my previous point, the rules or the laws target industrial and waged workers, whilst informal workers remain uncovered by protection. So what does this mean for air quality management? If clean air is a human right, it's a human right for everyone. So that includes extending responsibility on employers to ensure that their workers are provided with clean air at work, or otherwise provided with the necessary mitigating equipment, such as masks or air purifiers or ventilation. But we still have this problem of reaching informal workers who are really a huge part of the economy across Asia. And so this is a huge gap still. And we should also be considering not just ambient air, but also indoor air. This means that we have a right to clean air in schools, in hospitals, and other public spaces. And inequities need to be addressed. So, for example, if we're looking at government schools, there are still many schools, for example, that don't have air conditioning systems or any ways of keeping that polluted outdoor airs outside of the classroom. But at the same time, when classrooms are air conditioned, then it creates other forms of poor indoor air quality, such as very high levels of CO2, which can affect concentration and cognitive ability. And also there can be problems of mold as well in the classroom. So we really need a sort of targeted approach to be considering, to be offering all children equally clean air in schools. And to really target our action, we need continued data collection at different levels, including focusing on different groups of workers, focusing on school classrooms, and focusing on other spaces, public spaces, where people should be able to expect clean air. And then a final point, I think, is we can also link air quality management to climate change action, because many of the pollutants, including short-lived climate pollutants, are both bad for our health, but also very bad for future climate change as well. Thank you very much. I'll end it there.
Thank you very much, Ms. Archer. We are now approaching the end of our session. I would like to ask the floor if we have any questions for our panelists. Kindly introduce your name and country and organization before speaking.
Thank you very much, Glinda Bathan from Clean Air Asia. Director Pakorn, thank you very much for your presentation. I would like to ask, how closely are you working with other ministries in order to share the wealth of information that your office has generated, which is very important for clean air?
Thank you very much for the question. So this is a very good question, because I forgot to mention about this. So, so as we have talked earlier, sharing the data is the most important one. So we monitor it, we see it, but if other people cannot see it, the data is useless. So we share the data. We work closely with the Ministry of Natural Resources and also Ministry of Agriculture and also Public Health. So for the Ministry of Natural Resources, we share the data, and then we almost share the near real time of the air pollution data. So, and also for the Ministry of Agriculture, we share some of the crop condition like a cash crop, rice, sugarcane, corn, for example, and this to see the state of each crop. And we'll see what look like is likely to be burned after harvested. So different kind of the data that we shared. So, but also we have the like a direct line from the from the internet. We can share the data, and also we make the report every 2 weeks, every week, or not every week, sorry, every 2 weeks, I'm sent to the Ministry of Agriculture. So because we monitor the agriculture, particularly the cash crop, every 2 weeks. So hopefully, this is my answer for your question.